Welcome to the third questions in properties of wave. Below are two graphs which refer to the same wave. Determine the speed of the wave. Okay, I didn't see any speed here. How to find out the speed of the wave? And also the wave equation. Okay, good. First of all, we must understand this graph. What information can we extract from these two graphs? But first and foremost, I want you to pay attention to the unit of the axis. The unit, this is in meter. This one is in millisecond. Okay, what happened to the brush? Become smaller. Okay, this one is millimeter. This one is meter. Okay, so first of all, what information can we extract from this graph? This is a displacement versus time graph. This is the displacement versus distance graph. So we know that for both graphs, you can find the amplitude. So this is the, this is actually the amplitude. This is the amplitude. Yeah? What's the unit for the amplitude? Millimeter. That's why I asked you to check the unit. So amplitude is 6 millimeter. So for both, amplitude is 6 millimeter. And then the y versus t graph, you can find the period. Period is one complete oscillation. So for this one is the period. Okay, this one is the period. How long is the period? 4, not 4 seconds. Not 4 seconds, it's 4 milliseconds. And also for y versus distance graph, you can find the wavelength. Wavelength, this is the wavelength is in meter, so it's 0.8 meter. Not millimeter. Millimeter is for the amplitude. For the wavelength is in meter, 0.8 meter. Remember, this one show y versus time graph. It shows you the oscillation of one particle over time. But for that's why you can find period. Yeah, the time for that one particle to complete one oscillation. You can find the period of that one particle oscillation. But the y versus x graph, it shows you the whole wave. It shows you the whole wave. It shows you the whole wave. That's why you can get the wavelength of the whole wave, because you can see the whole wave profile, which has many particles. Okay, just want you to understand. So once I want to get the speed, very easy, because once I got the period, I can find frequency, which is 1 over period, isn't it? Once I have frequency and wavelength, I can just use the formula f lambda. Speed of the wave is v equal to f lambda. So f times lambda, I get the v, isn't it? So okay, let us do it. What's the speed of the wave? So first of all, my period I get from the graph is 4 milliseconds. The unit is so important. I put it red color. 4 milliseconds. And then the wavelength I extract from the graph is 0.8. What's the unit? Meter. Okay, meter. Good. Unit is meter. Now, yeah, I want to find the frequency. What's the frequency of from the period I can get? Remember, it is 4 milliseconds. So we must change to SI unit. Milli is exponent negative 3. Exponent negative 3. So the answer is 250 hertz. That is the this hertz actually is because this one you change to the time period you already change to second, because you already the milli you change to exponent negative 3. So the unit now is second. So your frequency is actually per second. Per second. So per second actually is hertz. The same meaning, yeah? Per second actually is hertz. And then I have the lambda in meter. So now I can find the wave speed. V equal to f lambda. Okay? Which is 250 per second. Yeah, that is a frequency multiplied by the lambda, which is 0.8 meter. The lambda is in meter, isn't it? Yeah, lambda is in meter. Lambda is in meter. So, what's my answer? Yeah, 200 meter per second. Meter per second. So I always be careful with the unit. The unit, don't ever put millisecond. You never change to second, then it's wrong. You must change to SI unit. Then only you get the correct answer. That's the speed of the wave. Okay, now the next one, it asks for the wave equation. Assuming the wave is moving in the negative OX direction. Okay, what is actually negative OX direction? Okay, negative OX means negative X direction. What is mean by negative X direction? It means to the left. The wave is traveling in negative X direction. Negative X direction means to the left. To the left means positive KX. You put positive. To the left is positive KX, the formula. Okay. So use the general formula. But first of all, we know is positive KX. Now, okay, we must find the amplitude. We have the amplitude, which is 6 millimeter. Okay, write it down. My amplitude is 6 millimeter. Be careful with the unit. You must change to SI unit. Yeah, amplitude is 6 millimeter, so it is 6. Change to SI unit. Because ini amplitude is follow displacement millimeter. So it's 6 millimeter. So it's change to SI unit. Negative. Sorry, yeah. So now negative 3. Change to SI unit already. Okay. Now or it is 0.006 meter. That's my amplitude. Now, what is my, I have my frequency. Yeah, I have my frequency 250 hertz. Or 250 per second. So find my omega. I can find my omega, which is 2 pi f. 2 pi f, which is 2 pi times 250 per second. So what's my, it is 500 pi radian per second. Yeah, my frequency is per second, so my omega is radian per second. Okay. Now, what is my wave number? I need to find the wave number also. I got my wavelength. Wavelength is 0.8 meter. My wavelength is 0.8 meter. So my K is 2 pi over lambda. My K is 2 pi over lambda. So 2 pi over 0.8 meter. So my answer is 2.5 pi radian per meter. Because my lambda is meter. So my K is per meter. Alright. So I already get my A, omega, and K. Now we just enjoy putting them into the general formula of A sine omega t plus minus kx. Plus minus kx. So direction is to the left. So to the left is positive kx. So this one must change to positive. So okay, write it down. Yeah. So y equal to this is 0.006 amplitude meter. Sine my omega is 500 pi t, and then put positive and negative. Positive kx. Positive kx because to the left. To the left is positive kx, and then my k is 2.5 pi x. That's it. Okay, so what's my unit for all? So just now I get my already changed to SI unit. That's why I have no worry. My amplitude already changed to meter. So my Y is in meter. I already changed the omega. I already changed to the omega to radian per second. So my omega is per second. So my time is in second. And then my wavelength is meter. My K is per meter. My K is per meter. So my X is in meter also. My X is in meter. So, and then I must write the unit. Yeah, don't forget your unit. Where just right below here lah. Yeah, right below here. Where Y and X in meter, both in meter. Okay. Right. Wait. Okay, both in meter. Sorry. Both in meter and T in second. Yeah, that's the answer. X and Y in meter, T in second. Okay, that's how you do the find the equation. So first of all, okay, I just want to revise with you. Remember to check the unit. The amplitude follow the displacement unit and millimeter. The period follow the time, millisecond. Okay, speed. The y versus t equation, y versus t graph give you the period, y versus distance graph give you the lambda. Period, you can get frequency. Once you have frequency, then frequency times lambda, you get the wave speed. F lambda, v equal to f lambda. Okay, get frequency times lambda, you get the wave speed. So you see this graph, you can find the speed of the wave. And then the direction, negative x direction means to the left, positive kx. To build the equation, if you want to build the equation, always start with this formula, a sine omega t plus minus kx. You just have to find out what is the amplitude, what is the omega, what is the k. Using omega to 2 pi f, omega k equal to 2 pi over lambda. And then also check the unit in the end. Okay, check the unit. Make sure you give the unit of x and y, and also the time. Okay, check the unit. Just substitute all the a, the omega, and the k. Then you get the answer. Pretty simple, isn't it? All right. That's all. Okay. Thank you for watching. Thank you for your time. Okay.